Hello, mathematicians. Welcome to day 5 of lesson 30. Today we refine our work on points, lines, rays, and angles. All right, here we go. How many obtuse angles does a rectangle have? It's a quadrilateral. Quads have 4 sides, 4 angles. How many of them are obtuse? Yes, I agree with you. It is a big fat 0 because we have a right angle, a right angle, a right angle, and a right angle, and those are all 90 degrees. Obtuse, you got to be bigger than 90. Tricky. In the shape below, list each pair of parallel sides and circle the letter marking each obtuse angle. Look at how you can show your work. Right angle. What kind of angles are B and C? Pair share. Okay, on page 667, list each pair of parallel sides and circle the letter marking each obtuse angle. So it gives you 2 things to do there. List the pair of parallel sides. Look at how you can show your work. Okay, so those are the obtuse angles. Right there, right here, and right there. So we're just circling that. What kind of angles are angles B and C? So angles B and C are smaller. They are acute. They're less than 90. You could find a handy dandy 90 and see if you're not exactly sure, but they are less than 90. Sometimes you can use these, or you can use paper and it's kind of see-through and you can see the dark lines. Sorry, that's me pressing buttons there. So that is possible. All right. So a solution down here. Look at how you can show your work. So that's angle A and angle D are the 2 obtuse. So we did that. List each pair of parallel sides. Okay, so you got AB is parallel to CD, right? And then you also have AC on the other side here is parallel to BD. That's a D. All right, so a couple different things they want us to do in this, lots of different things. Put an X where each pair of perpendicular line segments meet in the shape below. Describe the angles that are not marked with an X as your pair share. Okay, so we find all the corners. Where do we have the perpendicular corners, right? It says put an X. There's one there. 2. Where each pair of perpendicular line segments meet. Okay, we got one there. Got one in there. We got one in there. And then technically this one and this one meets right there at a 90 and on that side. Quite a few. Describe all the angles that are not marked with an X. Well, okay. They either have to be obtuse, right? Bigger than 90 or less than. This one right here is going to be an acute. Put an A there. This one from here to here is going to be way obtuse. D, really big angle. Same thing here. That angle is obtuse. And this angle is obtuse. So really, we just had one acute. We had 1, 2, 3 obtuse, and then a whole bunch of right angles. Interesting. A crosswalk is marked with a pair of parallel line segments that extend from one side of the street to the other. The distance between the 2 line segments from point A to point B is 6 feet. That number sounds familiar. 6 feet apart. What is the distance between C and D? This one was quite the setup to get to it. So yeah, if this is 6 feet and This is parallel, right? So what does that have to be? Yeah, 6 feet. Okay, that was like a lot of setup for a pretty easy one problem. Can the line still be parallel if the distance from C to D is 3 feet? If this was a 3 feet, no, 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 no. Because then it would look something like, well, kind of, depending on where the 3 feet is at, it look more like a trapezoid. Nope. To be parallel, you must be equal distance apart. Number 3, page 668. Toshi cuts 1/4 of a circle out of paper. How many angles does this shape have? Well, it just has from here to here. Remember, to make an angle, you need 2 rays to go together. We have a curve here. When you have the curve here, that's not going to make an angle. So it really has just the one. Esma chose D as the correct answer. How did she get that answer? She said 3. Does it make sense? Well, why do you think she got 3? If I erase this, oh, it's a nice big eraser now. That's sweet. Yeah, she got 3 because it looks like there's 3 parts in here, kind of like there's 3 parts of a triangle. And if it was a triangle, she would be right. So it makes sense that she kind of thinks that, except that to have an angle, you must have 2 rays, right? 2 rays make an angle, and rays are straight, not curved. Number 4, think about a real-world problem of where a wall meets the floor, where the wall meets the ceiling. So probably in the room you're in right now. Which term best describes what it looks like when these 2 surfaces meet? So if I look over to my wall, that's the window, but it meets the floor, and then the wall meets the ceiling up to there. Which term best describes? So where the wall meets the floor and the wall meets the ceiling. Which term best describes where these 2 surfaces meet? I would say perpendicular line segments. Oh, they meet at right angles. Looking up and looking at it, you see the lines go across and the lines go down. Okay, think about a real-world example where the wall meets the floor and that same wall meets the ceiling. Which term best describes what it looks like where these 2 surfaces meet? Okay, so where one meets here and one meets here, that would probably be parallel line segments. Interesting. I think I got a little tricked on that one. I'm going to go with A. I'm changing my mind. Kind of depends on your wall, so I don't know if this is the best question. But if you definitely think of like, okay, here's a wall and then there's the floor, right? If this is the floor, draw a picture. This is the wall. If you have a flat ceiling, okay, it would meet like that, right? And then there's the ceiling. So which term best describes what it looks like where these 2 surfaces meet? Okay, so this one's meeting there, this one's meeting here. Yes, I'm going to go with parallel line segments. I had to draw that one out. That one was confusing to me. Number 5, which drawing shows 3 lines? Definition of a line. 2 points form a line, right? And lines go on forever. So not this one, because we don't have lines. We've got line segments. This one, we've only got rays. What's wrong with this one? We just have 3 rays. So does this one have 3 lines? Yeah, 1 line, 2 lines, 3 lines. Winner, winner. All right, number 6 on page 669. Look at the shape below. For which terms in it is an example shown in the shape? For which terms is an example shown in the shape? Okay, so I guess which one of these terms is in this shape? Maybe there's more than one. Do we see parallel line segments? No, we do not. No parallels. Can't have parallel when triangles don't have parallel. Perpendicular line segments. We do. Right here. 1, 2. Right, those are line segments. Yes. Perpendicular. Yes. Do we have a right angle? We do. Right angle. That little square means the right angle. 90 degrees. Do we have an acute? We do. Right here. And right here. We have 2 acutes. Do we have an obtuse? No, we do not. So we had 3 of them there. That was a good one. Number 7 on page 670. Tell whether each sentence is true or false. A ray goes on forever in 2 directions. So we draw a little ray. Does that go on forever? Yes, but only one direction. So false. A line segment has exactly 2 endpoints. Yeah, that's kind of the definition of it. You can have more points on it. You can have a whole bunch of label a whole bunch of points, but the endpoints is true. An obtuse angle, dun dun dun, has a wider opening than a right angle. Is that wider than a corner? Yes. Parallel lines meet to form an acute angle. Parallel lines, do they ever meet to form any angle? Acute, obtuse, or right? Nicely done. Next one, it looks exactly the same. So let's skip that one. Number 8, Liz draws the 2 shapes below. Use words you have learned in this lesson to describe what the shapes have in common. How are they different? Again, on a t-shirt, common and different. Okay, so what do they have in common? They both have, 4 sides. Okay, I guess that's not really one of the things that we've been using. We have been talking about, so they do both angles because they're both quads. Do they both have parallel? Check for that one. Yes, they both common. 1 pair parallel sides. All right. Do they have any perpendicular? I guess they have that in common. No perpendicular. What about how many obtuse does it have? 1 obtuse, 2 obtuse. How many has 2? 1 obtuse, 2 obtuse. Okay, so they both have 2 obtuse angles. Boy, what's different? This one is long. This one has longer. This one here. Okay, they have different, like, what these are called, the line segments. So different line segment lengths. What's the main difference? They're both trapezoids. Both have 2 obtuse. So they both have 2. Those are obtuse angles. And these right here are what kind of angles? Yep, so they both have 2 acute. They mostly have a lot in common. The main difference is one is longer with the longer line segments on the top and the bottom. They might have a little different angle on the sides, but it's kind of hard to tell. All right, nicely done. Last one. Okay, math journal number. A triangle can have one pair of perpendicular sides? Yes, true. Can a triangle have one pair of parallel sides? Can you have parallel and then turn it into a triangle? Give it a go. Can you get it to work? Yeah, me either. So can a triangle have one pair of parallel sides? So here's some drawings to show how it does not work. No, you can have perpendicular triangles, you can't have parallel because you're not going to be able to close the shape. All right, you've got this. You are ready for the test. That's what it says behind this. You've got this. So give it a go, and I will see you next time. Nice job, mathematicians. Bye.